Hello everyone. I keep looking at the projector instead of the camera. My name is Samantha Snavely. I'm a full-time biology instructor here at El Centro, and I will be presenting the new old work that we've been doing with project-based learning and flipped classroom models here at El Centro over the last about 4 years now. So a little bit about El Centro, because about implementing these techniques in our classes, we started with our freshman entry-level general biology class. And so because it's a freshman level class, we do get students who are it's their first time in college. So a little bit of background on first-time students here at El Centro. Most are under the age of 25, but about 20% are older than that, not surprising for a community college. A little over half take at least one developmental course. There's a smaller cohort that get a pretty decent percentage that will take 2 or more, and almost half receive financial aid as well. Of course, we are an urban university or an urban college, and so there's a lot of dynamics that happen being in the downtown Dallas area that you don't necessarily see at other community colleges that are a little bit more suburban. So what we're seeing, the problem that we were facing with general biology, it's a very technical class, a very detailed class. We sometimes say that Biology 1406 is a lot like learning a language and then needing to apply it immediately. And what we were seeing was over time, and when I say over time, so maybe over the last 10 years or so, we were starting to see a gradual decline in student performance in Biology 1406. And the typical lecture-heavy class is, 80 minutes of the instructor standing there and a lot of verbiage, a lot of jargon to the students, trying to explain difficult concepts, oftentimes with a PowerPoint and drawings on the board, and the students sitting there taking notes, etc. And what we're seeing with this kind of typical traditional lecture class, we were seeing a very high drop rate and a very low success rate. And this chart here illustrates those three. So the lighter color here, that's the fail rate. This darker here, that's the drop rate, and only about, it's a third, about a third of the students dropping, about a third failing the class, and only about a third passing the class. And you can imagine that's very disheartening for the students, it's very disheartening for the instructors, and we were trying to figure out what can we do to try to set our students up for success. But although we needed to address some challenges, something that we were discussing amongst ourselves as seasoned instructors who've been teaching 10, 15, 20 years, is that we were seeing an increase in how underprepared our incoming students were/are in the classroom. They come in and they're not ready for the rigors of college, and many of them are not ready for the rigors of such a technical course such as Biology 1406. But they don't realize it. They have been challenged. They've not really truly been engaged. They might think they have been, but they haven't been at this level. It's something that we've joked about in the past, how on the first day we could jump up and down and say this is going to be a really difficult class. It's one of the toughest freshman level courses that exists, and pretty much every student in the class wouldn't think we were talking to them. They would think, oh, she's not talking to me, she's talking to someone else in this room, when in fact we're talking to probably 90% of students. They weren't really hearing us and understanding the level of rigor that this class was going to require. In addition to that, Biology 1406 doesn't have a specific prerequisite. It's a very technical and detailed class, and yet the only requirement is to be to college-level reading and writing skills, which are assessed by being TSI met in reading and writing, although there is no math requirement. And I think, as we all probably know, being TSI met in reading and writing is not necessarily the best metric to determine if a student is prepared for the rigors of a college-level course. Other challenges. Here at El Centro, a very large part of our student body, the majority of our student body, has a great deal of outside distractions. This is something that we've talked about with instructors at four-year universities, as well as instructors who teach with us and also teach at four-year universities, that our student body has tends to have a higher distraction rate than the traditional students that many four-year universities have. Most of our students have jobs. Many of them have full-time jobs. Many of them have families. Either they are serving as support for their families. They may have children of their own. I have had high school students who are taking my classes who have 2-, 3-, 4-year-old children at home. Some of them are helping to care for siblings. There's a lot of pull on our students there, and many are low income as well. We are a low income serving college here in the downtown Dallas area, and so there are a lot of distractions that we see. Many of these things, two or more of these details are affecting the student at the same time, in addition to the rigors of their coursework. Other challenges, and these are certainly some challenges that are not exclusive to any college or educational environment, is that there are oftentimes resources available to students, and they either fail to take advantage of them, they don't recognize them as resources, they don't think they need them, et cetera, until it's either too late or they just don't fail to realize that they're there at all. So some examples there. Here at El Centro and within the DCCCD, we have something called supplemental instruction, SI for short. The way SI works is that students that have been successful in a difficult course. We have it in math courses, we have it in several biology courses, chemistry courses, physics courses. So difficult technical courses, students who have been successful in the course and seem to have a kind of a personality for leading other students, actually come back and take the class again and then lead student study groups. It's a tremendously beneficial program. Students who attend SI regularly typically pass the course, usually very successfully with an A or B. It's really uncommon for a student who is regularly attending SI to fail a biology class that they're taking. But unfortunately, initially, students don't realize that they should be going. They think and they misinterpret that they'd be able to get by without much outside help with Biology 1406. In addition, we have a lot of resources that we build into eCampus. When we teach Biology 1406, we all start with essentially the same eCampus shell that we can then also add other resources to, but there are additional videos, animations, tutorials, things like that we have built in. I have a whole section of my eCampus shell called Study Tools that has a link of my study tips or a list of my study tips that I recommend to students. It's got a list of when supplemental instruction times are, and yet there's all these resources, but students won't review them. It happens more often than I would care to admit that students come to see me and I say, hey, have you looked at the study tool? And I say, oh, no, I haven't looked at that. And we go through it and go, oh, yeah. And even though I've been referencing or sending out announcements and emails, the students don't bother to look at the resources that are available to them. They also don't recognize their fellow students as resources. It's a somewhat natural that a lot of us have, that we want to try to be independent or work on our own and not necessarily rely on other individuals. And certainly students resist working in teams quite a bit, but it's something that they fail to realize that they actually can get a lot of benefit from talking with and working with each other. And it's very frustrating for us as instructors to watch them fail to recognize this until many times it's too late for them to be successful in the course, and now they're going to have to take it again at least one more time to be successful. So taking all of these things into account, this is how we got to the idea of let's start implementing problem-based learning here at El Centro in Biology 1406 classes. And problem-based learning goes by many names: project-based learning, Sometimes it'll be used interchangeably with flipped classroom models, active learning, things of this nature. And what problem-based learning does, there's been many articles discussing the benefits of using this type of learning approach. It puts students in a position of using more critical thinking, having to approach problems and materials in a different manner. It does incorporate social interaction a lot more. In our classes, we have them working in teams both in lecture and in lab, so it kind of forces them to utilize each other as references and resources. It does force them to be a little bit more active versus passive, instead of just sitting there taking notes or falling asleep in class. They actually do have to actively participate, because we've got them working in teams and working on activities. Some of the learning can be self-directed. Some of these details, as we're going to discuss in a few minutes, are students are doing outside of class or coming to class, and they can direct themselves to a certain extent. It also does help to make a little bit more aware of trying to find some of the resources that are available to them, say, for instance, that we've put online for them. And one of the big things that we were wanting to get kind of ingrained in our students was they needed to be touching the material multiple different ways at multiple different times. This is something that a lot of students really don't get initially. They think that they can come to class, take a few notes, read those notes before the exam, and be okay for the exam. And that's just not the way it's going to work in Biology 1406. It needs to be studied every day. It needs to be studied multiple different ways. And the study techniques need to be more active versus passive. So these were some of the benefits that we were hoping to reap by using PBL. So our thought process was, all right, if we start implementing these methods, then we will hopefully increase student success as well as student retention. So hopefully we'll see those drop rates and fail rates go down, and we'll see the pass rates go up. And so our thought process is, let's build certain requirements into the course that are going to force students to do what we need for them to do, what they already should be doing. Let's not give them an option. Let's make it part of the classroom culture, such that there's no way that they can avoid doing these things and studying the materials before they come to class. With in mind this idea of the multiple interactions and looking at the materials before they come to class, the biggest change we made with 1406 was following a flipped classroom model. And in so doing, what students do is, instead of coming to class and listening to us for 80 minutes talk about, say, cellular respiration or photosynthesis or the differences between plant and animal cells, the students watch lecture videos at home before coming to class. They also take notes on the videos as well as from their textbooks and other materials that are in campus prior to coming to class, and they are required to take an online quiz that's built into our eCampus system before they come to class. So this is giving multiple iterations of seeing the material, getting familiar with the terminology, familiar with the concepts before they come to class. And then that leaves time when they actually are in the classroom setting with each other and with us as instructors to do some hands-on problem solving. Let's test that knowledge. Let's take that knowledge a little bit further. We wanted to create a stronger connection between the lecture and the lab components. One of the things that we had seen over the years, which is not surprising, is that a lot of students will go to lecture and then they'll go to lab, even though it's directly after lecture, or they will fail to go to lecture and then they go directly into lab. And of course, students that do that are typically not successful in the class. If that's a regular occurrence, then the students are not setting themselves up for success. So what we started doing was instead of using a lab manual at El Centro, we use our own handouts that we've written with the material in them that we want the students to focus on. The lab techniques that are going to be used are listed out in those handouts, etc. And they are started, the handouts are presented in lecture, they're started in lecture, and then those activities are completed in lab. So there's a little bit more of this direct flow from lecture and lab. Some classes there's a little bit more of a connection than others, just by the nature of what we're covering in lecture versus the nature that we're covering, the nature of what we're covering in lab. But it still provides more than what we had before. We also changed in lab. We had been giving the traditional lab practicals as our lab exams, and we decided to change that up and started incorporating what we call lab projects. They are still completed in lab during an exam time, so still within that hour and 20 minutes that they would be in lab. But instead of it just being a timed exam where they have to identify a piece of equipment or maybe answer one question, it's a project that's going to bring together several different ideas from that unit, and the student has to kind of look at all of the information and then boil that down and answer questions. And I do have an example at the end that I'll be showing you. We do also have, as part of a couple of our projects, we have mini practicals as well, because we still wanted the students to be getting the experience of a lab practical exam, even if that wasn't going to be the only way that they were tested during the lab. This right here is a picture of the front page of one of our handouts, and so this would be a handout that the student would print out. It's available on eCampus for them. They print it out. It has objectives. The objectives are designed to give them an idea of, you know, by the time you finish this handout in this day class, you should be able to address all of these objectives. We have different exercises that are designated. You can see this one is designated as a lecture activity, so that's going to be addressed in lecture with the lecture instructor. And later in the handout, there are activities that are going to be addressed in lab. And that way, the student also has a good idea of what's going to be accomplished in class that day. So I mentioned that we wanted to build this into the culture of the class and make it required for the students to do this. Well, the only way that you can make it required is if you've got something, well, maybe not the only way, but we figured the best way for us to get student buy-in in some way, shape, or form was to require those written notes from the video, the textbook, the other sources online, as well as that class handout. We say those are the student's tickets to class. If a student shows up without either of those materials, he or she is not allowed to attend class. If a student shows up with notes and says, I didn't print the handout, well, you know, the computer lab on the fourth floor, run down there really quickly, print it out, come back, we'll get you in attendance. A student is not checked through on attendance that is not checked off until he or she is present in class with both the required notes and the handout for that day. And the consequence is that there are participation points that they lose if they're not there on time with materials that they are supposed to have that day. The participation points are not that much. It's only 2 points each day, but they do add up to about a total of, I think it's 40 points, 44 points over the course of the semester, which can definitely make or break a student's grade, certainly if they are in that borderline position, say, between an A and a B, B and a C, or a C and a D. So this right here is that kind of critical piece that will that helps to incentivize them, particularly at the beginning of class when they really don't understand why they need to be doing this just yet. And then we also built in that attendance in lecture is required for attendance in lab. And the way that we merge you so that lab instructors know if a student was in lecture is that the lecture instructor will sign off or stamp or hole punch or whatever method the lecture instructor uses. We'll do that as a handout, that class handout, so that the lab instructor can look really quickly and say, okay, yeah, you've all got your stamps, you've all got your signatures, you are all in lecture, so we're good to go. So some of our results. When we first implemented this, my fellow colleagues and I decided to try this in the spring of 2015 as a pilot. So in one of our classes, one of our sections, and we offer anywhere from a dozen to 15 sections of biology 1406 a semester typically. But we decided to run a pilot and see, does this seem feasible? Do we think it seems to make much of a difference? And what we saw in that class was on lecture exams, we increase of anywhere from 10 to 15 points on average on those lecture exams. And my colleague, who is also our biology coordinator, asked me at the end of the semester, so based on this, how many of our classes should we flip, and should we do this way come fall? And I said, I think we should do all of them. I think if we're seeing that kind of success, that kind of difference in our classes, we need to make that our baseline. That there's no reason not to do it, because we're basically setting the students up who aren't in the types of classes to not be as successful, and that doesn't seem appropriate. So the results you see here are based on fall 2015, as well as spring and fall 2016. And I believe we've also got a little bit of spring 2017 thrown in here as well. And the differences that you see here between instructor A, instructor B, instructor C, and instructor D. Instructors A and B are both full-time instructors. Instructors C and D are part-time instructors. And I'm going to touch on that little detail here in a little bit. But this particular graphic is showing us about the drop rate, and the difference in the drop rate, that almost a third of our students dropping in that traditional lecture-heavy format, versus this dropping down to less than 30%, close to about a quarter of our students in this project-based learning, problem-based learning, flipped classroom model. And this was a statistically significant difference based on t-tests that we ran to kind of analyze this result. So we get to actual grades on exams. So the orange bars here are representing, again, the traditional classroom, the blue bars representing the project-based learning classroom. And when you get over here to exams 4, 5, and the final exam, the grades are pretty close, but there's something very special that's happening here that we have to really tease out and think about, which is the week that we give exam 4 is also the week of the drop date. Every semester, the week of the drop date is also the week of exam 4. And typically, if students are going to be successful in the class, they have figured it out by about this point. And the students that are going to drop have typically dropped by the time they get to exam 4. And the students who are failing or maybe not as successful oftentimes have stopped coming. And so we see that exam 4, 5, and the final exam are pretty close, because by the time we get to that point in the semester, the students that are left in the class have a pretty good idea of how to be successful and pass. This is the part that was really interesting to us, because this is when you still have those, our classes top out at 24 students, because our labs top out at 24 students, the ability to start with 24 students in a given section. So here in this part of the semester, we're still in the relatively early part of the semester, where relatively few students have dropped the class. And so the ability to see a significantly higher average on exams 2 and 3 is really important for increasing a student's self-esteem, their ability to believe that they can be successful in the class, kind of gain a little bit of momentum going into the latter part of the semester. So the fact that we see these really strong differences in these grades on exams 2 and 3 was really meaningful for us, the fact that they're able to do really well. Exam 1, there is a little bit of a difference, a little bit of an increase with the project-based learning model. Again, what's happening with a lot of students before they get to that first exam is that they are underestimating the class. They're underestimating how difficult it's going to be, and most of them don't realize it until exam 1 lands in front of them. And then after they've taken exam 1 and they get it back and go over it and see that they didn't do that strongly on it, then that's when we start to see a lot more of the buy-in from the students at that point. So the overall results with the drop, pass, and fail rates, so this is that same pie chart that we saw at the beginning of the presentation, and here's what we see with the PBL model, where you're seeing that we've gone from about a third of the class passing to approximately half of the class passing, which is that's hugely significant. We're now at a third. We've got roughly a quarter that are dropping, roughly a quarter who are failing, and then we're at about half that are passing the class. It is important to note these data do not reflect hybrid classes, so those classes that are the lectures online and the lab component is the physical lab where they perform their experiments. Flex courses that maybe start a little bit after the beginning of the semester and may end a little bit before the end of the semester, the official 16 weeks, or night courses. So these are Monday through Thursday, say Monday, Wednesday, Tuesday, Thursday day courses here at El Centro. So challenges. Cost is one because we did have to develop some materials, and we were really, for the most part, we were able to apply for a little bit of funding, but a lot of this we were doing on our own. A lot of this we were funding ourselves, and in the interest of having low and no cost materials, we invest a lot of time because it usually means that you're building your own or making your own materials. We all, as full-time instructors, started doing a lot of research on what's a good activity for this type for this chapter. What's a good activity for this particular subject, or whatever the case happens to be. And then we would come together and talk about, okay, so which techniques do we think we want to work on in class, and ones should we actually work on? There's, of course, faculty buy-in. This is one of the questions or sticking points that a lot of people have when it comes to going from that traditional lecture-heavy course into a project-based learning course. All of our full-time instructors teaching Biology 1406 here at El Centro were and have been completely on board. So all of those that were part of our full-time teaching instructorship when we started this in 2015 to our current instructorship with new incoming full-time instructors. Everyone has been fully on board, really excited about it. Part-time instructors, for the part, are very interested, but they don't have as much time because most of the time part-time instructors, of course, are working at other locations, they have other jobs, and they just don't necessarily have as much time to invest in building materials, building activities, coming up with new ideas. But for the most part, our lectures are almost exclusively taught by full-time faculty members who then work with either full-time faculty in lab or our part-time faculty in lab. So we haven't had too many issues with faculty buy-in, but that is not to say there haven't been some. Some of the changes that we've made since we implemented this, because we've been doing this now, again, about 4 years. Initially, that first semester, that first fall of 2015 semester, all lecture instructors were utilizing the same lesson plans and the same instructional methods. So if we had come together and decided, hey, this is the activity that we're going to use to talk about osmosis and diffusion and tonicity, we were all doing that exact same using that exact same activity. And as we all started to get comfortable with our own experience with the flipped classroom model and with project-based learning, we developed some of our own methods. And as is so often the case, you also realize that maybe you have a certain class or a certain section that isn't responding to some of the activities or some of the techniques as well as maybe is typical for other classes. And so you start to come up with new activities and new techniques to try to apply to those core cohorts individually. So now we're in a system here, 3-4 years later, where instructors, we pretty much are developing our own techniques, our own activities to bring into class, but we have a lot of collaboration. That's one of the really special aspects about full-time instructorship here at El Centro is that we really work together and support each other, and so we collaborate with one another, and say, hey, I'm really struggling with how to present. I'll just go to osmosis and tonicity since it's fresh in my mind. What have you been doing? What have you found? And a lot of times someone will have something, oh, I just read this great article and I got this idea. Oh, okay, I'll detail that. Sometimes we'll come together and go, man, none of us have figured out a way to make sure that they don't get molarity confused when they get to that. So we'll still keep brainstorming and bouncing off ideas off of each other. Also, I mentioned that we were implementing this in that general freshman biology for science majors 1406, but the PBL methods have been carried through to some of the upper level classes. Biology 1407, which is actually really much more of a science biology majors requirement and not just an allied health nursing majors requirement. Some of our A&P classes and micro classes are utilizing more of these kind of project-based learning models. Some will utilize the textbook, say for instance this semester in biology 1407, instead of requiring the students to watch videos to take notes, the instructor who's teaching that course is saying, okay, use the textbook. Let's see how to do with utilizing the textbook to take notes. And that's something you can get away with if you've got students that are a little bit more seasoned and a little bit more familiar with the technical jargon. It's one that doesn't work as well with biology 1406, since it's the very first biology, really, significant biology class that most of our students are taking. Some examples. So I've got an example of an activity that I use in lecture, an example of an activity that we use in lab, and then also an example of one of our lab projects. So this is actually an activity that I came up with this year after attending the very first EPIC presentation with Dr. Chandler. Yes, okay, wonderful. While Dr. Chandler was presenting his work with his groups outside of the math classes, I was getting some ideas and brainstorming, and I came up with this idea here for students to study the differences in cells. So when we get to the chapter on cells, they need to understand the difference between prokaryotic and eukaryotic cells. They also need to understand the difference between plant and animal cells, which are within the umbrella of eukaryotic cells. So I came up with this idea, and this is just one of the scenarios that I came up with. But this is a paragraph that details a certain cell type. But as I have here, there are 3 errors, no more, no less, 3 errors, and in teams, and the teams are typically 3 to 4. I totally agree with Dr. Chandler that if you go less than that, you can sometimes end up with students or teams that just won't self-start. And if you go more than that, you invariably end up with students who aren't working, and they're watching other people work. So in teams of 3 or 4, they determine which 3 items need to be fixed and correct them. So in the body of this paragraph, there's enough information that should lead the students to, it must be this type of cell, and here are theirs. And I had to give enough information here, I had to give enough detail that if they started going down one road and it was wrong, they would realize that they were changing more than 3 details with the paragraph. So with this particular paragraph, the details are those. This paragraph actually describes an animal cell. So it's a eukaryotic cell, and the ribosomes are on the rough ER, and it's the cells, lysosomes that contain the hydrolytic enzymes. And this is an activity that we do on the very first day where we're talking about Chapter 4, because, again, the students have, if they're doing what they're supposed to do, they've watched lecture videos online, taken notes, looked at the text, reviewed the materials, the other materials online, and taken an online quiz. So by the time they get to class, they should be fairly comfortable with at least some of the basics on the different types of cells. And then they can work in their teams and use their notes to answer these questions. And I had different scenarios for different teams, so that it was a challenge for everybody. This particular graph is showing us a lab activity, and the materials that you see here, not very sophisticated, not very technical. This is an example of our low-cost but high-time costly, low cost money-wise, but high cost as far as how much time had to be put into it, with building atomic models. There are some fantastic model kits out there that you can order from classroom supply companies and so on and so forth, but they're expensive, as I'm sure many of you are familiar with. They're very expensive, and if you lose a couple of pieces, it's very expensive to replace them. So when you're thinking about having the same kits that are going to be used by 13, 15 sections of the same class, there's no way that you're not going to lose pieces, you're not going to get something misplaced, so on and so forth. So we said we want model kits that are inexpensive enough that they are really easy and cheap to replace. So this is what we came up with. So using poster board and markers, buttons, magnets, and laminating machines, that's it. I think that's all of the materials we have here. We created these templates for the different orbits for several common elements. Then we created these little symbols to put on there so that they would know which was which. The buttons that Velcro on, of course, represent the electrons. And then the little strips that we have are used to represent a covalent bond. So here in the water molecule, we have a strip that's representing the two shared electrons between hydrogen and oxygen here, and likewise here. And we also arranged it so that we could show the polarity of the bond with the button electrons being pulled more towards the oxygen than the hydrogen. This is an activity, as I've mentioned, that they do in lab, the students perform in lab, but we set up a lot of this with lecture, the activities that they're utilizing in lecture, going through and drawing the different chemical structures and orbitals of the different atoms, making sure that everybody's on board with, where do we find the electrons, which are the valence electrons, which ones are going to represent the shared electrons in a certain bond. So we've done a lot of laying that groundwork in the lab component, so that hopefully when they get to lab, they can jump right in with building their models. And then, so an example of a lab project. This is the very lab project that we developed, and we call it the atomic crime scene, and it is for the very first unit. And it dovetails off of what we just saw in that previous graphic with the chemical symbols, because this unit is very heavy on the metric system, understanding atoms, building molecules with those atoms, and then building the large biological macromolecules with those atoms. And so the scenario that the students have is, morning, atom thieves steal precious atoms from different atom museums around the world, and each student is going to get a kit of evidence and a list of potential suspects, and then each student has to solve their particular crime. And there are, as I mentioned, we have 24 students in each class, so there are actually 24 different kits of evidence. And then this directive for each suspect is what leads the students to the correct answer, hopefully. So they have, and this information for the suspect leaves items with a length of however many centimeters, uses a solution that is acidic or flammable, has a history of stealing atoms, so on and so forth. So there's descriptions for the suspect, and the students with their kits are they're going to weigh the pieces of evidence, they measure the pieces of evidence, they examine cards or descriptions of a solution or other particulars related to the crime scene, and then from that they find the thief that stole their particular atom, and they explain why on their answer sheet. So something that's a little bit more fun than maybe a traditional practical, but also has to, kind of pushes the critical thinking envelope a little bit. So as you can see, both of these, our lab activity here and then the lab project, they're low cost. We basically just had to come up with the ideas and then implement them. With respect to the project here, the items that the students are measuring that are in their evidence kits are things like paper clips or markers or golf pencils. So items that we might just have laying around the lab prep room that we could put in to be their evidence. So really low cost and easy implementation, but also testing the students in a different way. So that is, for the most part, my basic presentation. So now if anyone has any questions or comments, I would be happy to take those. Go ahead. Often use students the way to go out there with the worksheet. So just in case anyone didn't hear Rebecca's question, how often do you have to turn students away who don't have their notes or their worksheets? It doesn't happen very often, at least not in, I think, well, like I said, it's full-time instructors that are primarily teaching the lectures. It's pretty uncommon. I tell students on the very first day that I don't give any grace periods, and I don't because the very next class period, we're going over chapter 1, which is the least intense chapter of the semester. And if I'm going to turn anyone away, I'd rather be that day because it's the least critical day of the semester. And if they get turned away once, they typically don't ever do it again. They were, oh, okay, so you were serious when you said we couldn't get in. And the other students see that and go, okay, she means it. She means if you don't have the handout, you don't have the notes, you're not going to be able to stay. It's more common for a student to show up without the handout. I things like a student comes up and goes, oh, I left it on the printer downstairs. And I say, well, run and go get it real quick, go get it. And I try to encourage them to say, if you can get back, you'll get it on time, and, come on. It's less common that they show up without notes. But I typically 4 or 5 or 6 lectures a semester, and it's probably in the single digits any given semester in total that I have to turn students away. They realize pretty quickly that, now you'll have students that just don't show up, and maybe they don't show up because they didn't have their handout or they didn't have a note, but then again, they miss out on this participation point. So it's the students that are pretty serious about the class, which most of them really do want to do well. They just don't realize how much work it's going to be. It's fairly uncommon that you have to turn them away, which is good. It's anything we ever want to do.
This is maybe their feedback on how they enjoy this class versus any other science they might have taken with traditional lectures.
Some do. Rebecca's question is about student feedback and their impressions. Certainly at the beginning, you can tell on the first day when you're going over these are the requirements, this is what you are going to be expected to do. You can tell they're like, why am I taking this class? You can see it on their faces that they're not excited about the prospect. But we also tell them all classes here at El Centro run this way. So it's not a matter of it's just me or it's just that instructor. We're all doing it. So everyone has to do it. So you might as well just go ahead and get it because it's what's going to have to happen. I wouldn't say it's in every class. I do have students every semester who will say, yeah, I didn't realize that I needed to be looking at material, and I'm so glad that I'm doing that now. And then what's really satisfying is when you have students that go on to A&P or micro or other classes where maybe it's the requirements aren't the same, but they're using the same techniques. And they'll tell you, they'll stop you in the hall and say, I'm still taking my notes before class. I don't have to, but I know I need to because this is a lot of work. And that's okay. You the message. You understood the point. It wasn't just about making your life miserable.
Any questions?
You're very welcome. If anyone thinks of questions later, you can absolutely send them to Rebecca and she can forward them to me. I can, I've other examples of projects and other activities. So if anybody wants ideas, I'm more than happy to discuss.
Yeah.